What? You're still watching? We're on chapter 7, boys. Permissions management. I am surprised I have held your attention this long. Truly, you're either fascinated by Linux content or you have nothing to do with your lives. That's okay though. Life itself is meaningless, and we find meaning within ourselves and what we decide to spend our time doing. And if you wish to spend your precious life watching me go over Linux boxes, who am I to complain? I'm spending my life working on them and making videos. So let's talk about Linux permissions. That's the next step in our little journey here, right? If you're using a Linux system, first you need to know what Linux permissions are and how to modify them. First, let's start off with what they are. So let's talk about Linux file permissions. When you create a file on Linux, it assigns 3 owners to it. The first owner is, of course, the user. The second owner is the group. And then the third owner is your other, or everybody else on the system. So when you apply Linux permissions, it's going to apply ownership to one of those 3 groups. Ownership is set by default when a file is created. So the user creating the file becomes the default owner of that file, and that user's primary group also becomes the default owner of that file. So we've got our lab pulled up here. Let's practice making a file and see what happens with file permissions. So let's touch test file.txt, and then we echo test file.txt, so it has something in there, right? And then when we ls-l test file.txt, we see the permissions on the file we just created. The owner of the file is root. Remember, the creator of the file becomes the default owner, and the creator's primary group becomes the default group as well. So what happens when you're a user and you attempt to access a file? Well, the shell checks your permissions in 3 different ways. The first way is it checks if you're the user of the file, in which case it'll look at your user file and assign you the appropriate permissions for your user. The second is it checks if you have access to the file from your groups. So it'll look at your primary and secondary groups, and if you're part of one of those groups, assign that to your user and you have that equivalent level permission to your file. The third and final way is it checks if you're other, or if you're not part of those 2 groups, and then it assigns you default other permissions to those files. How do you check file permissions? Well, we've already gone over that. You use the ls command, or you use the ls-l to get a more informative output. Let's run an ls-al on all the files here. Haha, right, and you can see all the files inside of the root folder are currently owned by the root user and the root group, right? And you can see different permissions. So you can see read, write, execute. The ones that start with D are actually directories, and we'll dive deeper into that in further videos. Lots of useful information here. And you should get very comfy with this. You're going to be looking at a lot of files and a lot of file permissions when you're managing Linux systems. Everything is a file on Linux, so get used to managing them. Did you know Linux has advanced permissions? I didn't until I read this part of the chapter. This is breaking news for me, boys. Like, this is brand new information. So I'm gonna pretend like I know what I'm talking about, and I'd like you to do me a favor. Pretend like you understand what I'm saying. That way we're both playing pretend and we can have some fun. According to the book and my follow-up Google searches, there are 3, hear me, 3 advanced permissions on Linux. The first is set UID, or SUID. Let's dive into that. The set UID basically gives your user temporary root permissions on that file. This is a very dangerous permission to set on your files. Be careful, boys. So off screen, I ran a ls-l user bin pass wd. This is the result right here. The first part of the result, if you'll notice, is read, write, S. S stands for SUID. So on this particular command, or on this particular program, owners have the ability to run this command as root. This is useful because, well, we need to be root to change our passwords under that user's account. But we also need to be root to modify our etc passwd file, which holds our passwords. So set group ID, this is the same thing as set UID. Most of the time, you're not going to apply set group ID to files, because then everyone in that group would then have root permissions to run that file however they wished. However, people do use set group ID and apply them to folders, and there's a reason for that. Remember, on Linux systems, there is no file inheritance. So if you want to create a folder that is inheritable, a fix or hack for that is to create a folder, then set group ID on that folder, and then every file created in that folder will automatically have the appropriate permissions written to it. This is very useful, and we're going to walk through an example of it. We have two users here that I made, Chris and Tom, and both Chris and Tom are part of the accounting group. Let's make a folder for the accounting group and see what happens when we try to make files as Chris and Tom. So make dir /account test, and then let's cd into that account. So here's what we can do. We can do a change mod g+s, and you'll see underneath this folder, we now have the set UID permission set. So with the set group ID now assigned, what we then have to do is change the ownership of this file. So what we can do is change to, let's see here, change own, and then we want to change the owner to accounting, and then we want to change the local folder. And then from there we switch to Tom. And then as Tom, we should be able to touch file 1. Let's do ls.h and look at permissions here. It says accounting set UID read. We still don't have write permissions. Okay, so let's exit, and then let's give ourselves write permissions to this folder. So that's chown, let's see, group +w /. That's change mod group +w /. Let's talk about the last special permission, and that is the sticky bit. Technically, the sticky bit always applies to your other group, so keep that in mind when using it. Now, what does the sticky bit do? Well, it keeps your files stuck wherever they are. Basically, it disables the ability to delete those files. This is very useful if you have like a shared folder and you want files inside of that shared folder to not be deleted by anybody. Yeah. Hello. Did you know that there are more than just file permissions on your Linux file? There's also these things called attributes. What are Linux attributes? Well, Linux attributes are basically special features we apply to the file, or I guess you would say special rules or conditions that are applied to the file. How do we change Linux attributes? With the change attribute command, of course, or change attribute. Right? If you actually try to say the Linux words instead of what they're doing the shorthand for, you're going to end up with nonsense. Let's go ahead and get started and work on changing attributes. Hold on, I was getting ahead of myself there. We also have to talk about what the attributes are first. Helps if you know what you're changing before you actually go in and change it. Don't make that mistake in production. There are about 9 attributes. Honestly, you only really need to remember about 3 of them, so we're going to go over those 3. If you do want to know about the rest, Google search it. You're an IT person, hopefully. Google is your friend. It's my best friend, actually. The first attribute you should know is lowercase a. Lowercase a allows files to be added but not removed. The next attribute I recommend you burn into your memory is capital D. So what does capital D do? Well, capital D skips the step where Linux writes information to RAM and makes sure that Linux writes information directly to disk. So normally on Linux systems, when you write to a file, you're not actually writing to that file. What happens is you're writing to RAM, and then at some point later, determined by the kernel will write the contents of RAM directly to that file. This speeds up write performance, but it makes it so that if you have a database, it might take a long time for your server to shut down. This kind of forces that step to be skipped, so all writes are written directly to that file and not to RAM. The downside is that your database is going to be a little slower. The upside is your database is probably still going to be there if you have to emergency shut down your Linux server. So it's a very good upside. Trust me, you don't want to spend a couple days restoring a VM because you messed up a database. The last attribute is the lowercase I attribute, which makes files immutable. Basically, that means you cannot delete that file. This is very useful in case you have some files that you want to make sure no one on the server is ever able to delete for any reason. Okay, so now that we've read the theory, let's put things into practice. You can't learn unless you actually try the things you're reading out. Let's get started. The first thing we do is we go ahead and log in. Then afterwards we have to elevate ourselves to root. So let's do that real quick. And there we go. After that, we create a file. So to create a file, we do touch my file. So now let's change my file to an immutable file. To do that, we do change attribute plus I, lowercase I for immutable, and then we do my file. Now when we try to do rf/my file, you'll see even though we're root, we're not able to delete that file. We have the highest level permissions on that system, and even that user still can't delete it. So to confirm that we also just make changes to that file, you can do ls attribute. You'll see nothing else here has attributes applied except for the my file, which we just apply the immutable attribute to, which is this I right there. And that does it for this video, boys. We just learned how to change attributes. Swing by next time for chapter 8, where we go over Linux networking. A very riveting subject, I'm sure. Hello and welcome back. Last time we left off talking about file permissions and how they kind of worked. We're going to talk about how they work some more in this video. Let's get started with some simple utilities to manage file permissions. Ooh, I know you're excited. More tools to learn to master. This tool is called Find, and what does it let you do? Help you find stuff on Linux servers. How very convenient. Let's go ahead and mess around with it. Let's say we wanted to find all files on this system that belong to the user called test. To do that, we'll do find slash, so slash is the root of the file tree, dash user, and we let it run. And then after it's done running, you see it finds all the files and folders that belong to the user test. Very convenient and useful command. You can also use find to filter by groups. So if we were to do find slash dash group, and I think we have a group called Betty, and let this run, and let's see what happens here. So we have one folder owned by the user Betty, and that's it. That's FARDB sudo lectures B Betty. So very convenient. Let's talk about changing file permissions and ownership on Linux files. How do we change file permissions on a Linux file? Well, there is a command for that. That command is chown for change owner. Convenient, yes? Let's practice using that command so we can actually get good at using it. You gotta practice to get good, boys. Strange how that works. Let's practice using that command so we can actually get good at using it. You gotta practice to get good, boys. Strange how that works. So what do we want to change the ownership on a folder? Well, there's a flag for that. We have to use the capital R flag. So inside of our current working directory, we have a folder called test folder. It is owned by root. Let's change both test folders ownership as well as the ownership of all the files beneath it. To do that, we do change own dash R test dot slash test folder. Forgot the N in change own. There we go. And then when we go back to ls-alr, we'll see this folder is now owned by test instead of root like it was just a few seconds ago. Right? And that's how you change the ownership on a directory. What if we want to set the user owner and group owner of a group at the same time? Well, the change own command actually lets us do that. Let's try it out. In order to do that, let's say we have file 2 here that is owned by root. If we wanted file 2 to be owned by test, we would do change own, and then we will set the owner to test, and then we will set the group to sales, and then we will do /file 2. And then when we do ls-alh, you'll see file 2 is now owned by the sales group and the test user. What if we want to set just the group? Well, we can use the change own command to do that as well. That's pretty simple to do that. We're going to use file 3 as our test mule here. So to change file 3, we'll do change own, and we leave the first part blank, and then we do colon, and then we do sales, and then we point this at /file3. So we're leaving the owner alone and changing the group. And then when we do ls-alh on file 3, you'll see the owner is now root, but the group has changed to sales. My preferred tool to change ownership on files is change ownership. Very easy to remember. There is, however, another tool that will let you change group ownership. That tool is of course called change group. Let's work with it for a little bit. You don't really need to know it once you understand change ownership, but hey, the book wants you to know, so we shall know. To use change group, we simply do change group, and then we enter the name. To use change group, we simply enter change group, and then we enter the name of the account, in which case we're going to use sales, and then we're going to point it to the file we want it to do. So it's going to be file 4. And then when we ls-alh, we can see file 4 is now part of the sales user group, where before file 4 was part of the root user group. Thank you for watching. We have now learned how to use both change group and change owner. Please stay tuned for more as we learn more Linux stuff. I hope I'm keeping you riveted and entertained. So we've talked about chown. Let's talk about it some more. Did you know chown has a recursive mode? I didn't, at least not until I read the chapter. And now that I've read the chapter, I can convey that information to you. Very, very convenient here, this entire ecosystem we have set up. I broadcast my voice, and your minds happily receive the information. And at the end of the day, we both leave having learned something. Now, let's talk about recursive change ownership. The way it works is you use change mod and you apply your permissions using characters instead of the binary values. So if we wanted to create a file and give it execute permissions, we would do the following. Let's create a file called touch_test.bin. Now let's do an ls-l, and as you can see, test.bin is read writable, but it's not executable. So if we want to make that file executable, we would do change mod plus x to give it execute permissions on /test.bin. Now when we do an ls-l, you'll see test.bin is now executable all the way through. If we wanted to change the group using change mod, we would use the G flag. So let's say we wanted to give groups write permissions to test.bin. What we would do is change mod G plus W accounting /test.bin. Now when we do ls plus L, you'll see accounting now has write permissions. So that's a lot easier to change permissions on a file than it would be to just use the change mod 770. Depending on how comfortable you are with the binary notation of file permissions, the recursive version of change mod might actually be easier to use. I prefer the binary notation version just because it's what I've gotten comfortable with over years and years. It's easier to type numbers than it is to type letters and characters for me. So let's do a quick change mod exercise. Let's make a dir called temp, and then let's cd to temp. Cool, so now we're in that folder, and we're gonna copy everything from etc A to E. Cool. Now let's do ls. Cool, and we got some files here. So we copied a bunch of etc files to our temp directory. Now let's try changing ownership. If we do ls-l, we'll see we have root read write on a bunch of these folders right here. So what we want to then do is change mod a plus x /* to affect all the files, and then when we ls-l, we have execute permissions now on all these files, which is honestly very sketch. You don't want to have files just sitting around with execute permissions if you can avoid it. But hey, this is a lab. It's okay to have things be a little janky. Hey guys, remember a couple minutes ago when we talked about primary groups? Well, let's talk about them again. When you create a new user, for instance, we use user add Jake, and then we do groups Jake, you'll see there is a Jake group created along with the Jake user. On Linux systems, when you create a file, that file gets assigned the primary group of the user who created that file as its default group. So if we wanted to change the default group of a file for a user, we would have to change the primary group of that user. So how do we change the primary group of that user? Well, that's simple. We use the new group command. So we're logged in as root right now, and if we were to run a ls-lh, we'd see that we have a grep.txt already, and that file was created by root, and root's default or primary group is root. To change the primary group, we use the new group command. First, we list our groups. To do that, we do groups, and then we see root and sales. From groups, we then add a new group. So we do new group, and we'll add accounting, and then we'll list our groups again. And you'll see now we have 3 groups listed there. Now what happens when we make a file? Let's try it out. Let's do touch file2, and then we want to do ls-l to view all the information. You see we now have a file2. The primary user is group, but now the primary group is accounting, and that's because we changed the primary group on the root account. So remember, boys, use new group to change your primary group, and that changes the default group of files you make for that user. Let's talk about Linux permissions. What are the 3 Linux permissions, and what are they represented by? Well, the 3 Linux permissions are read, write, and execute. They can be represented as binary values. So the binary value for read is equivalent to 4. The binary value for write is equivalent to 2. And the binary value for execute is equivalent to 1. These binary values or file permissions are applied to your owners. So for instance, the owner or the user owner gets 3 permissions. The group owner gets 3 permissions, and the other owner gets 3 permissions. Unlike Windows, file permissions on a Linux system are not inheritable. So keep that in mind when you create a folder and set the permissions. The files inside of that folder do not automatically have the same permissions as the folder they are in. Just a little tip there. So let's describe what these permissions do. Obviously, the read permission allows you to read files and folders. The write permission allows you to write to those files and folders. And the execute permission actually lets you run scripts. So again, everything is a file on Linux. That includes your applications. And for your applications to run, they need the execute permission enabled. So how do you change and manage file permissions on a Linux system? Well, that's quite easy, boys. We've used this command before. We use chmod or chmod. So how do we use the chmod command? First, let's list our files. So you can see we have file 3 that is owned by root and accounting. And that file has read, write, reread permissions. What if we want to make it so that accounting group has read, write permissions to this file? To do that, we will do chmod, chmod, and then we want to do 6 because read is 4 and write is 2. Then we want to do 6 because read is 4 and write is 2. And then we want to do 4, and then we want to do ./file3. And then when we do an ls-l, you'll see here that file is now readable and writable by the accounting group. And we know it's writable by the accounting group because it's in the second set of permissions, which is for our groups. All right, boys. Well, welcome back to another episode of Low Spec Labs. Before we get started, I would like to say thank you for giving me your precious energy, your delicious attention span. I enjoy it so much. And in exchange for your attention, I'm going to data dump some knowledge into your brain holes. So let's get started. In this video, we'll be discussing lab exercises, more specifically lab exercises 7.1 and 7.2. These 2 lab exercises go over permissions. It's basically a review of the concepts we just went over in the past few videos. Let's get started. This is the fun stuff, boys. This is what we live for. Excuse me, I got a little too excited there, boys. Let's get started. So step 1A is to go ahead and log in to your server and elevate the root permissions. I've already done that. All right. So after that, we have to make 2 folders. So we're going to do make dir-p data/data/data/accounting. And there we go. So after we made those folders, I then added a user called Linda and added Linda to the accounting group. Now what we can do is list the ownership of those folders. So when I run an ls-l, you can see we have that data directory. When we cd into /data, I run another ls-l, you can see these 2 folders, accounting and sales, are owned by root. So what we want to do is change the primary owner of these folders and then assign Linda to those groups. Let's continue. First we go up a level. So we do cd. Then from there we do shown to change ownership, Linda sales, and then /data sales. And then we do change own Linda accounting /data accounting. After that, we're going to change the permissions on that file. Let's use the change mod command to do that. Okay, cool. So now what we should be able to do is become Linda. So let's do that. And then ls or ls-al, right? And then we can cd into /data sales. And then we can touch sales file 1. I hope that kept your eyeballs entertained. I know it kept mine. Let's talk about lab 7-2, working with special permissions. This lab assumes you've already done lab 7-1, so scroll back through the video a couple seconds. I'm not sure I'm going to splice this up and review that if you haven't already. Otherwise, let's continue marching forward, boys. You should be logged in as the user Linda. Once you're logged in as Linda, we're going to cd to the sales directory. So let's do an ls cd1 ls cd sales, and then clear. We're now in cd sales or data sales. There we go. Now that we're in data sales, we're going to create a couple files. So let's do touch file 1, file 2. After that, we have to become the Laura. After that, we have to exit our user as Linda, become root, and then switch over to Laura. We don't have Laura. Laura user mod -ag sales Laura. After that, we cd back into sales, and then we're going to touch file 3, file 4. Then we're going to do ls-l grep file, so we can list the file permissions. So you can see file 4 was created by Laura, while file 3 or file 2 was created by Linda, right? So notice how it assigns the owner of these files to the user that made them, rather than to the higher level owner of the file, which would be sales. So if I do ls-l ... to get the permissions of the higher level folder, you'll see sales is the default group, but that group doesn't get inherited by users. That group doesn't get inherited. Basically, whoever makes the file in that folder becomes the owner of that file. So how do we get around this problem? First, you become root. So you do su/ and then you enter the password of the root account. Then you cd back to /data, and then you do a change mod g+s to make that folder sticky, so the permissions of all the files below that folder match the appropriate folder permissions, and then +t to keep people from actually deleting that folder altogether. And then we enter the path of the folder, so data sales. Now when we do an ls-l, right, you'll see sales is now sticky, and it also now has the special bits set in the others field or in the group field. From there, we can cd back to sales and then switch back to Laura and then do an ls, right? And then if we do touch file 5 and we do an ls-l, you'll see file 5 is made by Laura, and now the owner group is sales. So now it's somewhat inheritable. Again, Linux doesn't have inheritable file permissions. This is just kind of like a walk around to resolve that issue.